In 2024, the Nobel Prize in Physics went to two visionary scientists, John Hopfield and Geoffrey Hinton, for their groundbreaking contributions to understanding complex systems and neural networks. It's a prize well deserved after decades of dedication that brought revolutionary insights into physics, biology, and artificial intelligence. John Hopfield, a physicist and biologist, is famous for bringing insights from physics into the world of neurons and brain function. Born in 1933, Hopfield had a unique mix of interests that pushed him to explore how physics could explain patterns of behavior in biological systems. He made a name for himself with the Hopfield network, a model that imitates how the human brain remembers things, storing memories like a massive, intricate puzzle that always finds the right piece. Geoffrey Hinton, a computer scientist born in 1947, is known as the godfather of AI and a true pioneer in neural networks. Hinton was inspired by the brain's complex system of neurons and believed it held the key to creating intelligent machines. His early work often seemed futuristic, but he pursued it, proving that machines could mimic human learning. Hinton's contribution to deep learning, specifically his work on backpropagation, laid the foundation for modern AI and machine learning. Hopfield's work took a daring leap. He created a model in the 1980s where artificial neurons could store memories. The Hopfield network uses an associative memory approach, meaning it can recognize partial patterns and retrieve the full memory, much like how our brains work. This model is still used in AI and physics to explain how systems stabilize. Imagine being able to recall entire images or ideas just from a fragment. That's the genius of Hopfield's contribution. In the 1980s, Hinton proposed that machines could learn in layers, which was the start of deep learning. He devised backpropagation, an algorithm that helps networks adjust themselves to learn from mistakes, similar to how humans learn. His famous neural network experiments and the Hinton capsule networks model are now the backbone of everything from facial recognition to voice assistants. Thanks to Hinton, AI can make sense of complex data, mimic human language, and learn from experience. Hopfield and Hinton approached neural networks from different perspectives. Hopfield's model gave insights into biological systems by applying physics principles, while Hinton applied neural networks to develop artificial intelligence. Together, they provided the toolkit for what we now recognize as modern machine learning and AI. Their combined efforts unlocked new ways to think about systems, whether it's neurons in our brain or algorithms in a computer. In 2024, the Nobel Committee acknowledged that Hopfield's and Hinton's pioneering models are now foundational across multiple fields. By creating a common ground between biological networks and machine learning, they established methods that scientists and engineers now use to predict behavior, recognize patterns, and simulate intelligent behavior. This cross-disciplinary impact was crucial in earning them the prize. Though Hopfield and Hinton made their discoveries decades ago, it's only recently that the world has fully realized the significance of their work. Their models have been adopted in everything from scientific research to the tech in our smartphones. The Nobel Committee recognized that their pioneering efforts form the basis for AI and cognitive models, both of which are shaping our future. Hopfield and Hinton's work offers the possibility of more human-like AI, systems that think, learn, and remember in ways we never thought possible. Their models are not just about creating smarter machines, they are pushing us to understand the human brain better, which could have enormous implications for medicine, robotics, and beyond. John Hopfield's work on neural networks wasn't his only claim to fame. He also pioneered research in protein folding, using his neural network concepts to understand how proteins shape themselves. To a multifaceted scientist, Hopfield's contributions have crossed over into quantum computing, proving the adaptability of his theories and models. Known for his humility, Hopfield is often seen as a professor of the people, consistently supporting the next generation of scientists and fostering a collaborative research environment. Geoffrey Hinton is a descendant of the renowned mathematician George Boole, the father of Boolean algebra, making his leap into AI seem almost preordained. Although he joined Google in the 2010s, Hinton was adamant about keeping his Canadian research team, ensuring Toronto became an AI research hub. Hinton's mentorship legacy is unmatched, with many of his students now leaders in AI worldwide, showing his influence extended far beyond his research. Dedicated to accessibility, Hinton embodies a true spirit of mentorship, sharing his groundbreaking work to inspire future innovations in the field. John Hopfield and Geoffrey Hinton didn't just win a Nobel Prize, they set in motion a journey that blends physics, biology, and technology. Their discoveries are bridges to the future, and their impact on AI and neuroscience will be felt for generations. Here's to celebrating two scientists who dared to think differently and changed the world in the process.